chapter 1, you're looking at about 2 to 3 weeks. Sorry, going through puberty. 2 to 3 weeks, losing my voice. We've got to do 1, 1, 2, 3, 4, 5, 6, maybe, and then 9, 1. So you're looking at all of those sections in your textbook. If you have the loose leaf textbook, you can put the just-in-time review stuff up and get the chapter 1 out and switch it. We are now in chapter 1. We are starting 1, 1 today. We will not finish 1, 1 today. 1, 1 is dense. And then the 1, 1 My Math Lab homework assignment, you should start it today as well. Do not wait on those My Math Lab assignments because, remember what I said, the day we finish the notes, you with me? Let's say we finish 1, 1 notes tomorrow. Then that means I'm going to set the due date, what's tomorrow, Wednesday? I'll set the due date to Thursday night. You see that? So, with the homework, you started as soon as we start the notes, and it's due a day after we finish the notes, every time. Otherwise, the highest you can make is a 90. Okay? So, keep that in mind. You will enjoy 1, 1 for... You will enjoy 1, 1 because it kind of covers stuff that is a little like elementary compared to where we're going with it. The difference is the questions that we're going to practice are putting together a lot of concepts all in one question. That's the difference. You know, you're no longer really in that, here's the question and it's only one concept that you have to know. Now it's connecting all the dots. By the way, the fishing team tryouts, or I don't know if it's a tryout, but you can wet a line without, you know,
I can wet a line.
wrapping your neighbor up in the line. I would say they take it. Yeah. Yeah. All right. Looking at introducing to graphing. Here is the first thing you need to understand is the name Cartesian coordinate system. You already know it as the coordinate plane. Anytime we are graphing coordinate points, we do have the x, y. X is the horizontal movement, y is the vertical movement. It's the equivalent of if you were trying to go in a building and go to a meeting, you have to first walk into it, right? Before you get on the elevator. You with me? So you first have to walk into the building, then you get on the elevator and go where you need to go. So if you would, as best as you can, because I realize, oh, it copied pretty well. I want you right now to graph and label these points on your paper. When I say label, you can call the first one A, the second one B, C, D. You see where this is going? So if you will, graph and label those points. And I'm really sorry for the way I sound. It's not going to get any better. say your answer for media is off of my Or it's like question media, question media. Yes. I don't remember if 1.1 requires the media there so that you can see the media is an option. And then I get to 1.2 and it might let me take it off. Make sure you're not doing that while I'm doing the notes. All right, so let's make sure you got these. So -3, 5. We got 4, 3. 3, 4. 3, -4. I'm trying to go quick, so if I messed it up, be nice. Oh, messed the letter up. That. All right. Does it match yours? Okay. Do you remember a couple of order of business things? Do you remember what this is called? Yep. 0, 0 is the origin. Do you remember how to name the quadrants?
Clockwise.
There you go. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you're taking my pre-cal class, you need to be able to say the quadrants. If you struggle with the quadrants, you need to practice it because that is a common theme in the pre-cal class. And if you struggle with that, it's gonna aggravate you. Here's a technique that I use in naming the quadrants. So this is the coordinate plane, right? Yeah, coordinate plane. What's coordinate plane start with? Coordinate starts with a C. How do you draw a C? Like that. So think coordinate plane, labeling the quadrants on the coordinate plane, go in the direction of drawing a C for coordinate plane. So let's take some notes. Right here. Think of writing A, and then I'm going to draw it C for O-O-R-D-I-N-A-T-E, coordinate plane. When labeling quadrants. Alright, if you have a highlighter, you might want it for the next part. If you don't, I have plenty right here. If anybody wants one. I'm going to alley-oop it. There you go.
The shoes.
She's about to take it. Anyone else? Alley-oop. All right. Equations in two variables, like 2x plus 3y equals 18, have solutions of the form xy. How do you know it's a solution? Well, because if you substitute the point into the equation and it makes a true statement, then that means it was a solution. If you substitute the point into the equation and it makes a true statement, then it's a solution. Please go to this example. It says determine whether each ordered pair is a solution to the equation, and please verify yes or no. Show your work. have the coordinate point of the form xy. You're going to plug it in. And you're going to verify if the left equals the right. Some people, when we get to this point, they're like, I'm not really sure what to do after that. You're going to evaluate the side that has stuff there that needs to be cleaned up. You could just type this in your calculator if you wanted to, or you could do it in your head. Negative 10 plus 21. It doesn't matter how you do it. But you would bring down what you get, and then this is a statement of equality, and if it's not true, you would slash it and say, no, 11 does not equal 18. So no, negative 5, 7 is not a solution. For B, what did you get? So if you go and plug X and Y in, you get 18 equals 18, which is true. So yes, 3, 4 is a solution. Something to keep in mind, which did not play a role here, but it can come up. But that's supposed to be an asterisk. Oh, it's terrible. Make sure to use parentheses for negative numbers. And that's because if it's something squared, if you don't use parentheses, your calculator is going to keep it negative when in fact a negative number squared is positive. So be careful. It's not supposed to be a gotcha, but that's where some people get caught. All right, go to the next section. Looking at the graphs. Good old-fashioned graphing linear equations. Okay, what's the purpose of a graph? Bless you. If I said, what's the solution to 2x plus 3y equals 18? You could say 3, 4. That's a solution. Which means if I was to go and graph 2x plus 3y equals 18, it's going to pass through the point 3, 4, because it's a solution. What if I said, what are all the solutions to 2x plus 3y equals 18? Do you have time to list them?
No, you have to graph it.
You have to graph it. You cannot list all the solutions to a linear equation because you will never get there. It's infinite. It's a line, linear. It's going. So the purpose of the graph is to represent the solutions so you can visualize where they are, since nobody has time to sit down and write them all, okay? Some methods to graphing. You can do the good old-fashioned y equals mx plus b, or there's what's called graphing using the intercepts, which is really helpful. Now, there's a condition that has to be met, otherwise it's not helpful at all. But basically, if we can find the x-intercept and the y-intercept and connect them with the line, we've got the graph, okay? Intercept, what does that mean? It's where it's crossing those axes, right? So we're going to find the x-intercept and the y-intercept. Well, if we're talking about the x-intercept, what value from the coordinate point is naturally given if we're on the x-axis. We're given 0 for the y coordinate. We're finding the x. So it's very intuitive. If you're finding the x-intercept, that means you're looking for what number is x when y is 0. If you're finding the y-intercept, you're looking for what number is y when x is 0. See that pattern? Okay, so let's take some notes. We're going to graph by intercepts. Notice this is the exact same equation from the last slide. So if we're going to graph the x-intercept, that means it's of the form x comma 0, right? Which means let y equal 0. Which means plug it in for y and find out what x is. So if you come up here to your equation, here's why graphing by the intercepts is so convenient. If I plug 0 in for y, this does not become 30, it becomes what? 0. Which means I'm left with 2x equals 18, x is 9. Graphing by intercepts can be done in your head, which is why I love them. Now, there is a caveat to it, and that is it doesn't work every time, and I'm gonna give you that stipulation in a second. So the x-intercept is 9. You could say, so the actual coordinates are 9, 0. We're going to repeat now with y. The y-intercept is on the y-axis, which means x is 0. Coming up here to the equation, if I plug 0 in for x, this goes away. Be careful, because if that was negative 3y, the negative would be there, right? So don't accidentally mark out the sign of the next term. I would be left with 3y equals 18. So y is 6. Now we graph. And then we do the best we can. Helps if you make noise. Yeah. It really does. Okay, mine's not exactly straight, but that's okay. Y'all are going to just write it down and we're going to move on so nobody knows. So that was graphing by the intercepts, not by slope-intercept form. Don't confuse the two. But wait a minute, there is a caveat before you change your notes. Caveat means fine print, disclaimer, be careful, watch out, object on road ahead, right? GPS. This only worked out nice because what happened when we plugged 0 in with these numbers? They divided nicely, right? The coefficient was a factor of the number that was left. So that's basically the caveat is don't use this method if C is not divisible by A or B. Because in that case, this is ugly. So I'm going to label this as A, B, C. And I'm going to come over here and I'm going to say note, make sure when I write C over A, that's saying C will divide by A nicely. And then, of course, C over B, we're going to write the word nicely. So if C will not divide by A or B in a nice either whole number or a half, a decimal that's a half, then I wouldn't go that way. Which brings us to the next slide to say, okay, well then what would you do? Well, so the next slide is an example of when C will not divide nicely. Yeah, because she said she was going to come down and close this one off. So look at this one. We've got A is 3, B is -5, C is -10. Now you could still find one of them if you wanted to, but then you're just mixing techniques and that would probably be a mess. So let me show you this alternative way. The alternative is, you remember this, slope, intercept, form. Slope-intercept form. Y equals mx plus b, where b is the y-intercept of the form 0, b, or 0, y. It's up to you. You could write either. It's the y-intercept. So you can write 0, y, or you could write 0, b. They're the same thing because b is the y-intercept, so you could write it in the form 0, the number. In order to use slope-intercept form, you may remember this, you need it to be in slope-intercept form in order to be able to say the slope and the y-intercept. This is not. This is standard form. You need slope-intercept form. So you're going to solve for y, which is why we practice solving literal equations, because this is a literal equation. There's very few numbers in there. You got your two variables. So let's take it. 3x minus 5y equals -10. The goal is to get y by itself. So I would cup game that 3x over, which means it becomes negative. Now, you could tack it on the end of the -10. I personally like to put it right after the equal sign because of the mx plus b format. And then I need to divide by -5. Red means wrong here. Maybe I shouldn't do red. Well, red's always wrong. It's not that it's wrong. It's, let's say this. It's not helpful. What I'm about to show in red is not helpful. If you say to yourself, okay, I'm going to move -5, it's division, and you come over here and you do that, it's not helpful because now you can't clearly see the slope and clearly see the y-intercept. So when you divide by the coefficient of y, I'll change colors. I'm going to divide this away by coming underneath each item. Think of that Ruth's Chris restaurant, a la carte. I'm going to go underneath each item and divide. And the reason for that is because, look right there. -10 divided by -5 is actually 2. That's a lot easier to graph than -10 over 5, -5. And I probably wouldn't have caught it as easily if I had done that one really big fraction. So now I'm going to write it nicely. Also, clean up any negative over negatives. Y equals 3/5 x plus 2. Now, we're going to graph this. I don't know how your previous math teachers taught you to graph this. If you remember, great. If you don't remember, let me show you a technique that I have trademarked, which is a lie. I have not, so if any one of you steal it, I'm going to sue you. It's on video right now. But I want you to write, begin with, shorthand for with, B, move with M. TM. That's my trademark symbol. So begin with B, move with M. Write it down. I'm going to explain it. What it means is when you're graphing this equation, it's just linear. A lot of people think slope is first because it comes first in the equation. And that's absolutely not true. Slope is not a point. Everybody say it with me. Slope is not a point. Sounds like we're all in therapy together. Slope is not a point. Slope is a direction to the next point, which means you got to have that first point plotted before you can move, right? So, hence the reason I said begin with B. B is 2. M is 3/5. Recall from Algebra 1, rise or fall if it was negative, over run.
We had a 7th grade teacher.
Let me guess. She laid in the floor, she stood up, and she ran out the room.
No, but she didn't like telling us that she was going to do it. She just.
I've heard about it. I've heard. Never met her, but I've heard that
crazy.
story.
Never read this
I've heard so much. I'm tired. But I'm not going to do that for you because one, I didn't prep for that. I'd be like, 2, I don't want to trip and fall because that's probably what's going to happen. But you can see, begin with B. I would definitely laugh.
To represent rise on the road.
So begin with B. Remember it was the y-intercept. And then now from here, you're going to count 1, 2, 3, up. 1, 2, 3, 4, 5 to the right. I know, I'm sorry. The graph didn't copy very well. And then now we can, ooh, that was bad. Now we can draw the line. That is so curved. Be kind and be quiet. Don't hate. By the way, if you're not really sure when you go to draw the line, you could also continue that slope. Oh yeah, it definitely should have been like a little bit over there. But anyways, you could continue that slope and do it again because it's like a staircase. Okay. All right. So you have 2 methods of graphing. You have the intercept method if it will work pretty. Then you have what works every time. Begin with B, move with M. This Holcombe's trademark. I'll try to make money off of it. All right, get your highlighter. Recall. You're talking about equations, right? Y is the dependent variable. Dependent, relies on, is set by, is determined by, is calculated by, varies based on what? X, which is said to be all on its own, independent woman, doesn't need a man, can do it on her own. Sorry, wrong class. X is independent and determines Y. Okay? Highlight that. Also remember, you can use a graphing calculator to graph equations that are already solved for Y. You have to have it in terms of Y, meaning Y is by itself, before you go to graph it in Y equals. Hence the reason the button is said Y equals. Okay? Also in your calculator, you do have what's called the viewing window. The viewing window is always of the form. Now let me explain it. L is for left, R is for right, B is for bottom, T is for tall. Tall is what I was looking for. Tall. Just kidding, top. T is for top. So it's your left bound, your right bound, your bottom bound, your top bound, okay? You've got to know this because we're going to be adjusting viewing windows a lot. And it's really helpful if this is not something we have to teach when we get to those problems. The standard viewing window, if you tell your calculator, just graph me the standard graph, is negative 10 to 10, both the x and the y. That's the standard viewing window. How do you get the calculator to graph the standard viewing window? You will hit zoom 6. You will hit zoom 6. All right. Now, do you have a calculator? Okay.
Just keys.
Okay. Go to this. Let me get my calculator. I had y'all get yours and I forgot to open my calculator. All right. We are graphing y equals x squared minus 9x minus 12. Okay, so we've been talking about linear equations. Now let's look at what starts with a Q. Question. Quadratics. Or quadratic. Let me take the S off because it's singular. Quadratic is another type of equation. You should be familiar with quadratics. It is when the expression has x to the second power in it, or if it was a binomial raised to a second power, if you multiplied that out, it would have x squared. So we're going to graph this quadratic. So first of all, you could graph by simply picking numbers for x, plugging it in, and then plotting the points, right? You could graph it that way. That's the good old-fashioned way to graph anything. Pick a number for x, plug it in, write what you get for y, and graph it. Or you can do what's called the table. The table on your calculator is the running t-chart of all the x and the y coordinates. First, let's put the equation in y equals. Push the y equals button. If there's anything in there, clear it. If the plots are on, raise your hand and I'll show you how to turn them off. All right, we should be good because we reset the calculators before that exam. We're going to copy the right side of the equation in here. This button is your variable x. Squared, you can push that button there, which will generate the squared, or you can use what's called the hat. This button that looks like the roof of a house means anything that follows it will be bumped up to an exponent's position. Minus 9x minus 12. We're going to graph this by going to the standard viewing window. That would require the button zoom. Notice option 6 says standard. Notice it jumps straight to it. Now, if I said to you, I can't see the rest of the graph, you would need to adjust the window. You can do that multiple ways. One, you can hit what's called zoom out. Zoom out. If you do that, there's a cursor that's going to say, okay, where do you want to center that you're zooming out? I'm just going to leave it right there. And now I can see the rest of the curve. It's not, I push zoom out and hit enter. It's not ideal though because the tick marks on the axes are so many. Now it's just busy, right? But I still can see the curve. Another way, if you were to go from this to something that you could see the whole curve, is to recognize which direction the axis needs to keep going. I clearly need more towards the positive x, more towards the negative y. So I can go to the window button, to the window,
To the wall.
Okay, we're still recording, so yeah. I could go to the. I could go. I'm singing it. I'm singing it. To the yeah. Just forget it. To the window right here, you can adjust the x-axis to the right and then the y-axis going down. To do that, it would look like this. You push window, and you would recognize if it's max implies to the right. So I'm just going to throw out a number. I'm going to say 50. Now, scale means how do you want it to count? You need to keep in mind, it's fixing to show 60 tick marks on the x-axis. So I tend to change the scale to either like 5 or 10, because I can't stand a ton of tick marks and then I just start getting lost in all of that. Then we said the y-axis, but going down, that would be y-min. Again, you're just throwing a number out there. You play around with it, it's guess and check. I definitely don't want 110 tick marks, so I'm going to change the y scale to 25. I don't know. And now, to get the calculator to use the window that you just told it, you have to hit graph from here. Otherwise, if you go back, Lord help. Otherwise, if you go back and you hit Zoom 6 or something like that, it undoes what you just tried to do. Now, you can see I went too far, but that's okay, because I can still see the bottom of the curve, and I can see where it's crossing the x-axis, and the y-axis, for that matter. So I could work with this window if I wanted to. And what do I mean by work with it? I won't sing that song, Rihanna, but you also could go to the table. Notice the button table is in blue. Notice the button second is blue. Push second, and I say table because we were going for the blue number. This is your infinite running T-chart. Okay? Infinite running T-chart. Now, you can change that if you don't want it to count by the nice, pretty ones. If you wanted it to count by 0.5 for whatever reason, you could change that by going to what's called table set. You can change that. You would push second, table set. It's going to say, okay, where do you want to start the table? I'll start it at 0. How do you want the table to count? You could change that to count by tens or count by 0.5 or count by 1. It's up to you. Auto means it's going to generate the whole list for you. Ask is helpful if we have really ugly numbers that are nowhere close to each other. It's going to be more word problems. Like, evaluate this function when x is 22.678. Now evaluate it when it's 143.5. Those numbers are really far apart. I don't want to sit there and scroll on that table. So I could type it in y equals, come here, tell it to start wherever it wants to, but then I can change this to ask, and it'll let me actually type in, okay, tell me what y is when x is, whatever that number was I said, when it's really ugly numbers. It will calculate it for you, evaluate it for you, okay? Going back to the table though. So there's your running T-chart. So you can see all the coordinate points that not are on the line, but that are counting by ones on the line. Okay, now let's put some notes on your paper. So you could make a T-chart, and I'm putting in parentheses, or table as some people call it. Normally the table would run up and down. I'm going to make my table run horizontal just because of what I plan to write next. So we have x, we have y. Was it 0, I think? Was it negative 12? 1 was negative 20. And I am not going to worry about the rest, so I'm just going to put ... You get the idea. Now, if I'm graphing this quadratic, I need some critical values in order to graph it. We already saw that it's kind of like that, right? Yeah? You can go ahead and do that as best as you can. We already saw that. What are the critical values? They would be the x-intercepts, the y-intercept, and do you remember what this is called? The vertex. So let's label the critical values for a quadratic are the two x-intercepts, if it has two. Could have one, could have none. This has two. The y-intercept, true or false?
True.
Georgia's going to win a national championship. Oh! I'm just kidding. It probably will because their schedules. What I was going to say was true or false. Every quadratic function has a single y-intercept.
False.
True. Let me say it again. It's okay. I'm glad you participated. Every quadratic function, I said function, meaning it has to be a function, can't be a quadratic turned on its side. Every quadratic function has a y-intercept. That is true because it will always be going out as it's also going either up or down. So it's always going to cross the y-axis eventually. And it will only cross in one spot. All right, let's take some more notes. So to graph a quadratic like this, you could just make a table, pick numbers, plug it in, graph it. Or you could find critical values and then sketch it. All right, so what are the critical values? Well, first, the vertex. Then you've got the x-intercepts. Which, by the way, are also called the roots, solutions, and zeros of the graph. Or you have the y-intercept. All right, now what we're going to do is show you how to use your graphing calculator to find those values on the graphing calculator. Now, if I go too fast with this, then I want you to practice it tomorrow in Flex, okay? Because it's very helpful to be able to do this. So I'm going to go back and make sure I've not messed anything up. All right, my quadratic's still there. I'm going to go to my graph. You do need a really good viewing window to do this. You want to be able to see where it's crossing x, where it's crossing y, and the vertex. You're going to hit second calc. Second calc. Might want to write that down. Now, everything is right here. You will notice it does not say vertex. It says min or max. So you've got to equate the picture, the direction the quadratic is opening to whether it's bottoming out and has a min or it's topping off and has a max. Ours was bottoming out, so we're going to select min. A cursor is going to pop up, flashing. Mine flashed. Mine flashed. I guess this one's not. Does yours flash like it's saying to you enter or move it? Is it flashing? Okay, good. So a cursor pops up that is usually on the graph. Oh, mine's on there. Look, mine's all the way up at 2208. So this is a good example of when the cursor is out of sight. You need to look at this. This is telling you right here where the cursor is. I'm clearly more in quadrant 4. That point is in quadrant 1. So I'm going to arrow left quite a bit. Oh, there she is. All right. There's the cursor. Okay, what's the point of the cursor? The calculator is going to ask you 3 questions. It's going to say, give me a left bound, give me a right bound, then give me a guess. I feel like a flight attendant. Give me a left bound, a right bound, a guess. Meaning, I need you to take this big old picture and narrow it down to this little viewing window so that I can tell you the vertex. So the left bound needs to be left of the vertex. So I'm going to keep arrowing till it's left of it. Doesn't matter how far left, it just needs to be the left, to the left of it. And what we mean by to the left is we are implying reading it like a book, right? Okay, so hit enter. You will notice a line appears, and now it's marking. Okay, so we're cutting it from the left here. Now we're going to repeat with a right bound. Another line appears. Now it's going to say, give me a guess, which just means put the cursor about where it looks like it's on the vertex. This does not have to be perfect. In fact, we're going to have some graphs where the cursor, for whatever reason, like skips right over the vertex. It jumps too much. So you just have to put it as close to it as you can. Then you hit enter, and then it's going to give it to you in coordinate form. Now, we are going to round this because that's ugly. So we're going to write this down. We're going to say 4.5 and negative 32 1/4. Now we're going to repeat with finding the x-intercepts. Notice I gave you 3 more words. Because x-intercepts has 4 total words to describe it. X-intercept, roots, solutions, zeros. All 4 of those words mean the exact same thing, nothing different. Why do we need 4 words for it? I have no clue. I don't know why that said, let's throw roots in there and zeros in there, but they all mean the same thing. So we're going to pull this back up. We're going to hit second calc. You will notice it will not say x-intercept, it's going to say 0. Push that. It's going to repeat the 3 questions, but you need to know what you're looking for now. I'm not looking for the vertex. I'm looking for the zeros. So you have to do this twice because there's 2 of them. You can't find both at the same time. So pick one and focus your attention on it. So we need a left bound, a right bound, and then a guess. And it will produce the coordinates for that. Then you'll repeat with the other one. Okay? I'm going to erase that and do it. So, left bound. And I'm just going to, like I'm near it right now. So that's going to be where I make my guess when that comes up. I'm going to go left of it 2 times. Hit enter. Now I'm going to go right of it. And I'm going to go back to it. So I think I wrote, I said, yeah, I just went with negative 1.2. Because we're just sketching. So negative 1.20. Now we're going to repeat with that other one. Second calc. Find the 0. Now we're going to go to the right. Or, well, not to the right. We're going to the x-intercept that's on the right. The first option, though, we need to be left of it, right? Oh, my word, this is getting confusing. Left of it, right? Correct? All right, I'm going to the right of it. Now I'm going to go back and hit enter. So 10.2. 0. And now the y-intercept. Well, 2 ways to do this. One way is to say to yourself, y-intercept. We just practiced that. That's when I'm looking for The y value when x is 0. So this is where you let x equal 0 and you plug it in. Guys, if the quadratic's in standard form, do it in your head. Here's what I mean by that. It's in standard form, and I'm about to plug 0 in everywhere there's an x. That means, numerically, that's gone. That's gone. All you'll ever be left with is c, if it's in standard form. So the y-intercept here, if I plug it in, is negative 12. Correct, 0. Negative 12. And then now what we're going to do is take some notes on our graph. So, right here, we're just pretending like those are the coordinates that we just found. Let's take some notes. The y-intercept, you could either plug x equals 0 in, or you can do second calc value x equals 0. I'll show you how to do that. The vertex was second calc minimum. The x-intercepts were second calc 0, and then it had 3 questions. So there's you some notes if you need help with writing those. Let me show you what I meant by this right here. Second calc value x equals. So coming back to this, let's say I forgot to just plug x equals 0 into the equation, and my mind's just thinking, I gotta use my calculator. So hit second calc. Notice option 1 says value, meaning, okay, what do you want me to evaluate this function at? Evaluate it at 0. Hit enter, and it'll tell you. Okay? So that's another way to do it. Now, normally I would keep going, but it's kind of a good stopping point because next is distance formula, then midpoint, and then equations of circles, and those 3 things go together. So this is a good place for us to stop 1-1, and we will finish it tomorrow. We still have 14 minutes left. The expectation is you should be working. Anytime there's like substantial amount of time left, you should be working. Also, because it's our very first time in my math lab, I want everybody to try to get into it. Because I know we had some issues on Friday. They said they reset them. You are going to need your phone in order to do the password. So if you want to go ahead and go get it, that's fine.